5.2 is ratios, proportions, and an introduction to similar figures. So we're going to start with some vocab. A ratio is a comparison of two numbers. With the same unit completely simplified, okay? So you want to make sure that you have the same unit, and then you're going to simplify out both your unit and any kind of common factors. So if we look at this first example, we've got 5 meters over 25 centimeters. And so to simplify this, the first thing we need to do is convert meters into centimeters. So there's 100 centimeters in 1 meter. So we multiply that by 100 to convert it to centimeters, and we end up with 500 centimeters over 25 centimeters, which means that our centimeters are going to simplify, okay, because we don't need our units in a ratio. It's just a comparison of how many parts to how many parts. And then there are 500 divided by 25. Well, there's 4 25s in every 100, and 4 times 5 is 20. So our ratio simplifies to 20 over 1. Remember that it's a comparison, so you want to have that second number there, 22 something, okay? The other ways that you can write this ratio are 20 colon 1, that means the same thing, or 22 1 with the word 20 to 1, okay? So I'll let you take a look at number 2. Just as a little hint, there are 16 ounces in 1 pound. So an extended ratio is a comparison of 3 or more numbers. Okay, so it's still just a comparison, but there are 3 or more numbers as they relate to each other. So for this example, we're going to use a triangle because there's 3 parts to a triangle. It says the measures of the angles in a triangle are in the extended ratio of 3 to 4 to 8. Find the measures of the angles. So that means we have a triangle. And for every 3 parts in this angle of the triangle, so we're going to call that 3x. There are 4 parts in this angle of the triangle, so 4x. And there are 8 parts, and again we're calling parts x. So 3 parts to 4 parts to 8 parts reduces to the ratio of 3 to 4 to 8. And then it's going to allow us to solve for angles. So we're going to use triangle sum theorem and say that the sum of these 3 angles, 3x plus 4x plus 8x, is equal to 180 degrees to solve for x. So we've got 15x here. And then we divide 180 by 15. 15 goes into 80 10 times with a remainder of 30. And we get 2 more 15s than 30, so x equals 12. We can solve for each angle. So we're going to substitute our 12 back in for 3x. And we know the smallest angle is 36 degrees. 12 in for 4x, that's 48 degrees. And finally 12 in times 8x, and that is 96 degrees. And if you check it, those angles should add up to 180. And they should also reduce to 3 to 4 to 8. Okay, so naturally after we are done talking about ratios, we move on to a proportion. And a proportion is an equation that has a lot of movement right now. A proportion is an equation with 2 equal ratios, like A over B is equal to C over D. Okay, so a proportion is actually an equation, and ratios are just comparison of 2 numbers. So the extremes of a proportion are A and D. They're the first number you say and the last number you say. So if you read this whole proportion, A over B equals C over D, A and D are the extremes. I like to say that they're living on the edge because they are the first and last number that you say. They are extreme. The means, mean represents middle, are B and C. So again, if you look at this, our middle numbers in our proportion, A over B equals C over D. B and C are the means, okay? And so to solve a proportion, we use the cross product property, and we know that if A over B equals C over D, then the product of the extremes is equal to the product of the means. All right, so to solve a proportion, we're just going to cross multiply. The important part is if you have a quantity, that you put that quantity in parentheses so that you distribute through and multiply it all the way. So 6 times x is 6x, and 2 times 3 minus x is 6 minus 2x. That's equal to 6x. If we add our 2x here, we get 8x equals 6, divide by our 8, and x equals 6/8 or 3/4 when it's reduced, okay? So I'll let you work through number 5. Make sure that you put parentheses around these two quantities and double distribute when you simplify that, okay? So a scale drawing is a drawing, okay, like a blueprint would be an example of a scale drawing. So it is a drawing that is the same shape as the object it represents, but it's a different size. So obviously blueprints exist because we can't print things in a 1-to-1 ratio. So that would be crazy and very expensive. The scale factor is the ratio that describes how the dimensions in the drawing are related to the actual dimensions of the object. Okay, so that is the scale. So you might have like a 1-to-12 scale on a blueprint, or a 1-to 64 might be a common one. Okay, so if we look at this example, it says the scale of a map is 1 inch to every 1,440 feet. Find the length of a street if the distance on the map is 3 inches. So here's the beautiful thing about proportions. You have your comparison right here. 1 inch to 1,440. Okay, and you're trying to find the distance, the length of a street in real life if the distance on the map is 3 inches. Well, in your comparison, you did inches over feet. So you're going to match that for your setup, and you're going to do 3 inches over an x number of feet, the number of feet that you're trying to find. And you're going to cross multiply. X times 1 is x. And 3 times 1,440 is, well, we can do this. Let's see here. 3,000 plus 1,200 plus 120. So we've got a 0, a 2, a 3, and a 4. So if I did that right, 4,320 feet. Okay, so, but proportions are fabulous because you just have to set up a comparison and then follow your comparison setup for the second comparison, and then cross multiply. Okay, we're gonna stop here, and I'm going to let you go ahead and work through these examples, and then you can, actually I think I'll just make a quick video on them, or you can work through them on your own and check your answers.